Yeah, the subject of the talk is constraint programming in Perl 6. What is constraint programming? Well, it's a form of declarative programming. And so I will first define declarative programming as a more general example. So this is a form of a model of programming where you don't have to state how you're going to do the things or what to do, but you specify, and you don't specify a control flow or a number of algorithmic steps to do something. It's declaration programming is non-imperative, non-procedural. What you do in general is you state definitions, axioms, rules, predicates, whatever, and then you use them to try to derive new facts, to derive theorems or otherwise properties of what you're studying. So there are a number of declarative programming techniques which are well known to most of us here. Database query languages such as SQL, regexes, grammars, logic programming, things like Prolog or PCAT, functional programming, compilation, configuration management, etc. More precisely, concerning constraint programming, what we have is we have relations between the variables which are stated in the form of constraints, which can be constraint satisfaction problems, something like, for instance, A or B is true, or it can be linear inequalities, or it can be equations, and some others. And what they do is they describe the property of the solution, the properties of the solution to be found. So what I wanted to do was to try to explore some form of symbolic computation, basically meaning that I'm trying to make a program that will automatically solve mass equations, or try to do that at least. Now I want to warn you, this is very much an experimentation. There is no beautiful shiny module associated to that, and with all bells and whistles and all these things. And I don't think there will be any in the near future. So we'll start with a simple example: the the Celsius to Fahrenheit temperature conversion. So let's consider Fahrenheit to Celsius converter. The temperature, the Celsius temperature, is equal to 5/9 of the Fahrenheit temperature minus 32. This can be this is quite easy to write that in Perl 6. This is just an example. Sub Celsius of Fahrenheit returns 5/9 of the Fahrenheit temperature minus 32. But if you want to do the other way around, then you have to write another subroutine. So the second one, sub Fahrenheit, return 32 plus 9/5 of the Celsius temperature. Now what I would like to do is to be able to define one formula, not to define two subroutines. Because here I have to do it one way. It's the same formula actually describes the two things, but we need two subroutines to do it with traditional procedural programming. So while the conversion is of course quite simple, so it's only 2 lines of code to define the two subroutines. But if we consider a more complicated math formula, say for instance the ideal gas law, we have 5 variables, well actually 4 variables and 1 constant. And this equation is not one directional. If you're given 4 of the values, any one of them, you can derive the 5th one, but you have to write 5 subroutines to do that in procedural programming. Well, maybe only 4, because the Boltzmann constant isn't going to be changed, but but the others will. Do we want to write 5 subroutines? Well, I would prefer not to. So let's get back to the Fahrenheit Celsius model. Here what we have on the scheme is 3 boxes. So the 2 boxes on the left are called multipliers, and the box on the right is an adder. They play the same role, except the 2 on the left make multiplications and the one on the right makes additions. So if we start with the Celsius temperature on the left, and we have a constant at the bottom left, then we can multiply A and B to get C. And C is propagated to the other multiplier. And C is now has a value. And if A or B has a value, then we can calculate the other one. And since B is a constant, it has a value, so we can calculate A. But we're not multiplying here, we have to divide, of course. It's a multiplier box, but it's, I drew it the other way around to show that we have to divide C by B in order to get A. And A will then be transmitted to the other box, and will be added to 32 to get the Fahrenheit temperature. Is this clear? So basically what I want to do is to code these 3 boxes. So that's more or less what I described. A multiplier box ports its terminals. It has 3 terminals, A and B and C. And if 2 of the terminals are set, like for instance A and B in the first example, then we multiply a value to get C and we propagate it to the other box. In the case of the middle box, is the other way around. We need to make a division because we have C and B, and we need to make a division to figure out what A is in the middle box. So this is a subroutine which takes 3 terminals as a parameter and calls something called ternary constraint with the terminals and with the needed arithmetic operation. So the multiplier, the code is actually a little bit more complicated than that, but I simplified it to this. It's basically it's first defining 2 blocks, multiplication block and a division block, and then it's passing to the ternary constraint the value of the 3 terminals, A, $B, $C, and the operation that it has to do depending on the case. So multiplication when we have the 2 value on the left, and division when we lack the value on the left. The ternary constant is then implementing this. So it's receiving the 3 terminals and the 3 arithmetic operations, and depending on whether on which terminals is defined, if we have 2 of the terminals, then we can find the third value by using the arithmetic operation which has been passed at the right place. So this is so all this is of course available to the user, but how is the user going to use this constraint programming? Well, it's not so simple, because rather than having to define the 2 small subroutines which I showed at the beginning, the user has to connect all the various bits and pieces, the C, the Celsius temperature, the F, the Fahrenheit temperature, and it has to make all the connections between the 2. So in the end, it's much more complicated than what we did at the beginning. So we're not simplifying very much our problem here, because if the user has to write a complicated thing like that just for a simple Celsius to Fahrenheit conversion, I think they're not going to use my module. But we can go. This is the user code like that is not very simple. But since this is Perl 6, we can actually simplify it, because we can use grammar to pass the math formula, and then we can automate the creation of the multipliers, the adder, and all the objects needed. So for now, what I have used is a very simple grammar which can pass math formulas only using multiplications and additions or subtractions or divisions, but not more than that. And one of the obstacles I found is I'm not sure what else I would need to make it more general, to make it really usable, in other words. Because, okay, it does work with simple formulas like that, but I think there are many more general cases which I can't really think about. Do I have time? Yeah. So anyway, lessons drawn. First, my implementation is way too complex. I made actually two implementations. One, the one you've seen bits and pieces, is a functional implementation. More recently, I tried to make an object-oriented implementation, but both of them are way too complicated. I mean, I'm lost in my code. Whenever I don't work on it for 3 days, and I don't remember what the thing does. So I really have to find a better way to do it if it's going to be useful anytime. The second point is I'm not convinced that this way is going to be very useful. Thinking about it, maybe some other people have other ideas, but the use cases are quite limited in numbers. So looking back at all this, I think we probably want to drop this this thing and to find another way of going this direction. And one of the things I was thinking of is logic programming. Perhaps something like Prolog or PCAT would be more general and enable to solve more general problems. So, among other things, I was thinking of Ovid has made a Prolog module in Perl 5, so maybe port it to Perl 6. Maybe it would be interesting. I know that Jeff Koff made some recently. Is he there? No, he's not. Oh yeah, he is there. Made some things on PCAT. I don't know PCAT at all. I mean, I only read about it for the first time about 3 weeks ago when you mentioned it in some of the things. So I'm not sure what to do with it, but maybe it would be more interesting than what I have been doing. And I mean, the reason why I chose a 20-minute presentation is because I think that it probably wasn't worth to spend 50 minutes on this, because it's probably something I'm going to abandon. I might come back on this decision later, but anyway, to conclude, this work was inspired in part by the book Structure and Interpretation of Computer Programs, great MIT books. It's a little bit old now, written by Abelson and Sussman, and also its adaptation to Python made by a fellow named John De Niro. Thank you for listening, and I'm open for questions. I have about 4 minutes for questions now. Yes? Sorry? Yeah, so the question is what kind of domain would be, for what kind of domain would this constraint programming thing would be useful? Well, the idea I had was, in that case, it was trying to do something like symbolic calculation. That is, you're using a math formula, for instance, and you're not trying to write an algorithm to do it, but you let the computer do it, and that's really what my original idea was, and it does work, but it's just a little bit too complicated. It would, if you had to do a lot, it would also probably be slow. But I mean, in general, we don't care about speed for such things. It's rather that I think it's too complicated for what it does, and there must be maybe a better way. And I think maybe logic programming might be a better way to go.
Can you hear me? Okay, now you can. So when you were talking about polling the terminals or everything, I thought that actually you were going to talk about using using channels and using whenever.
Using what?
Using channels or using tabs and using also whenever to implement that kind of thing. Do you think that that kind of asynchronous programming would be maybe a better model than just using subroutines and if and else and things like that?
Yeah, so the question is, if I understood correctly, you're suggesting that we could use asynchronous programming for solving some of these problems. Yeah, I guess it's probably right. I just didn't think about that. Yeah, maybe there's a possibility. I just don't know. I can't answer right now off my head. Any other question?
Okay. This is more of a comment about PyCat than a question. I found that PyCat is not the best at being embedded in anything. What I was frantically yak-shaving last week was a library to convert Perl, to convert C++ library over to Perl 6 for purposes of using what's called G-code, G-E-C-O-D-E. And that is G-E-C-O-D-E. It's a constraint and logic programming language that is done using C++ libraries. And I'm looking at binding that. So that may be another way to look at another venue.
Yeah. Maybe we can talk off in the hall somewhere. I think it's okay. So thank you for coming. Thank you for listening. Have a nice rest of the day. Thank you.